Okay, this is lecture number 19, and I'm going to talk about putting capacitors in series and capacitors in parallel. First of all, what we want to do is finding something called equivalent capacitance. Okay? What it means is this. Just imagine a battery with positive node and negative node, and the potential difference between these two nodes is V, right? Now, I'm going to put a capacitor with capacitance C1, and charges on the plates are positive Q and negative Q. Then I'm going to connect another capacitor, parallel plate capacitor, just like this. So this one will be also plus Q and this will be negative Q. Similarly for this one, positive Q and negative Q. It's a little bit crowded, but you can also see in your book, same picture. And the potential difference between the first two plates of the first capacitor is V1. The potential difference between the two plates in capacitor number 2 is V2, and V3 for the third one. The capacitance for first one is C1, for the second one is C2, and the third one is C3. So we want to know what's happening effectively, all right? So first of all, we have to notice that the voltage drop or the voltage difference between these plates for each capacitor is V1 and V2 and V3. It's just like when you climb from the first ground floor to the first floor, there is a change in the potential energy. Then after that, you go to the next floor, then there's another change in potential energy. And then you go to the next floor and so on, you change another step in potential energy. So the total potential energy change, the total PE change, is the sum of each change in potential energy. So this is the first change in potential energy, delta PE1, delta PE2, delta PE3. If you add them all up, you will get delta PE, total change in the potential energy. Similarly, the voltage drop here is V1, the voltage drop here is V2, the voltage drop here is V3. Then if I add V1 and V2 and V3, it must be the same as V. So the first equation we write down is V is equal to V1 plus V2 plus V3. So if you have more, then I write more. And if you have less, let's say 2, then I write only 2. If I have 5 capacitors, I'll write 5. Right? V1 plus V2 plus V3 plus V4 plus V5 and so on. Now, but the basic formula for capacitance for each capacitor is C1 is equal to C is equal to Q by V, right? C1 is equal to Q1 by V1, or you can write V1 is equal to Q1 by C1. And similarly, V2 is equal to Q2 by C2. V3 is equal to Q3 by C3. Right? This is 2. So, if I substitute it in this equation, then what I get is V is equal to Q1 by C1 plus Q2 by C2 plus Q3 by C3. But if you notice, because these are parallel plates, this one and this one, they have the same amount of charge, positive Q, negative Q, positive Q, negative Q, positive Q, negative Q. So this Q1, Q2, and Q3, they are all the same. So V is equal to Q times 1 by C1 plus 1 by C2 plus 1 by C3, because Q1 is equal to Q2 is equal to Q3 is equal to Q. Now, if I know that V is equal to Q by C, then I can write V is equal to Q by C, where this C is 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3, just by look at that. So I write this expression as 1 by C, then I'll end up with this equation. What it means is, if I draw as a picture, it represents a capacitor with charge Q on this side, negative Q on that side. Potential difference between them is V, and the capacitance is C, and is connected to positive node here and negative node here, right? So my drawing is not very good, but anyway, so that's the figure. So what it means is that by putting 3 capacitors like that, that's what we call in series, is equivalent to having one capacitor with capacitance given by C, where C is given by this formula. So that's why we call it equivalent capacitance. Okay? So for capacitors in series, then the formula for finding the equivalent capacitance is 1 by C is equal to 1 by C1 plus 1 by C2, etc. Right? So for example, let's suppose I have 2 capacitors in series, and this is, let's say, C1 and this is C2. And I want to find the equivalent capacitance, or a capacitor which will have the same effects as having these 2 in series. Let's call it C. In order to find that C, I have to use this formula. So let's say C1 is equal to 2 microfarad. C2 is equal to 3 microfarad. So C1 is equal to 2 microfarad. C2 is equal to 3 microfarad. Then what is C? The formula for this is C. 1 by C is equal to 1 by C1 plus 1 by C2. So that is 1 by 2 plus 1 by 3, which is equal to, this is 2 times 3 is 6, and 2 goes into 6 3 times, plus 3 goes into 6 2 times, so it's 5 by 6. That's not the answer yet. This is only this O. This is only 1 by C. Let me repeat. So I have 1 by C is equal to 1 by C1 plus 1 by C2, and is equal to 1 by 2 plus 1 by 3. So the common denominator is 6. So I have 2 times 3 is 6, and then 3 times 2 is 6. So I have 3 plus 2, so I get 5 by 6. That's not the answer yet, because it is 1 by C. So in order to get C, don't forget you have to flip that 5 by 6 around. You get 6 by 5 microfarad. Okay, so that's how you find equivalence capacitance. I'll do another example for you. So this time, let's say I have 3 or 4, let's make it 4 capacitance, another capacitors in series, so like this. So this one is 2 microfarad, this one is 2 microfarad, this one is 4 microfarad, this one is 8 microfarad. And so I want to find the equivalence capacitance for this arrangement of capacitors. Okay, so that means I want to find a capacitor which will have the same effects as having these four in series. So let's call it C. Then our formula is for capacitors in series. It is 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4, because there are 4 of them. And all of them are in microfarad, so I'm not going to change this unit. I'll just keep it as microfarad. So when I get the answer, it will be in microfarad. So 1 by C is equal to 1 by 2 microfarad plus 1 by 2 plus 1 by 4 for this one plus 1 by 8 for the last one. So I have common denominator here is 8. 2 goes into 8 4 times plus 2 goes into 8 4 times plus 4 goes into 8 2 times plus 1 time. So that's 10 plus 1, so that's 11. Excuse me. 11 by 8. Remember, this is not the answer yet. Oh gosh. 11 by 8, excuse me. So in order to get equivalent capacitance C, I have to flip this around. That's 8 by 11 microfarad. Okay? So I'm going to quit here for this lecture.